My name is Manvir Singh, and I'm the Scrum Master for Team Hearts. Let's begin.
Here's a quick overview of the user interface. Our app begins on the CIS dashboard, which contains two buttons, Registrar and Faculty Preference. These buttons lead to pages where each respective person can input their information regarding the class schedule. When you click on the Registrar page, there are a couple of buttons to perform different basic actions, such as search, edit, and delete. There's also an option to create a new record and to return back to the home page. The faculty member is essentially the same as the registrar page, as the faculty will also be performing the basic task of entering data.
Excel sheets that we will be importing into our system. The first pertains to the registrar, and this sheet contains information about the courses, as you can see here. The next sheet that we will be importing contains information about the faculty as well as their preferences, as you can see here.
And I'm gonna quickly show you how to edit this file. Click the edit and change one of the attributes, and this information change. Let's look at faculty preference screen right now. I'm gonna show you in this screen how to upload to Excel and export to Excel. So in this screen we have similar functionalities, and let's start to upload to Excel. First, we are gonna select our Excel file. We are gonna choose our template faculty preferences and select our Excel files and save it and import the file into the system. We import the records from Excel file to faculty member preferences screen and record it into the system. I'm gonna show you how to export to the Excel our records. So we click the export to Excel button, and system downloaded our faculty preferences recorded go through our Excel sheet.
In this section, I'll explain the logic behind the application. We have 3 data files and 5 states in our algorithm. Our data files consist professor's name, course name, and time blocks. First of all, we will use these files to create population, and then we will match this initial schedule with the relative preferences of professors. In population of schedules, we have 28 arrays of solutions. These arrays have 4 components, which are time, day, course, and professor's name. These arrays are just randomly generated by the algorithm. We will enter the evaluation module, which will basically evaluate how fit these schedules are in terms of professor's preferences. Algorithm will check all possible schedules, so it can compare chromosomes with each other. A higher fitness score reflects the best fitness of the schedule with preferences. Then we are ready to go to the selection module, on which we will recall chromosomes with an order of highest fitness score. Then we will pair them up in the crossover module. Child reflects the match of 2 chromosomes. When a child reaches to the top score, algorithm will stop. The schedule with the top score will be transferred to schedule page, and it will be displayed on the application.
Our first Java program outputs all of the possible schedules. Each digit represents a time block. 1 means it's taken, 0 means it's not taken. Our second Java function inputs all of the professor preference and compare with each of the schedule. If a request match one of the time block, we add 1 point to that schedule. Every faculty gets a list of score of all the schedules, and at the end, each schedule get a total score.
That's all for our product overview. Thank you very much for your time and patience.